Okay, guys, continuing on 7.3. So for trig, sort of a synopsis of what we just said, I can write any sine cosine function as follows. I can write it as f of x equals a times sine or cosine or tangent, whatever is relevant here, times b times the quantity x plus c plus d. We're going to identify what all these things mean here in just a second. A is the amplitude. That was how far it is from the top to the middle. A. B. B into 2 pi is the period. If we're in radians, we could also say or 360 divided by b is the period if we're talking about a degrees-based graph. So be careful for that. Make sure you're reading it appropriately. Am I in degrees or radians or what? C, the opposite of C, is our horizontal shift. Sometimes this is referred to as a phase shift. And D is our vertical shift. It moves, I have a note here that says moves midline, but technically it moves everything. I just use the midline to determine whether or not we're talking about what the value is of D. I really hope that you guys are taking the time to go back and really annotate these notes and put some more effort in there in looking at the graphs on your own time. This will not make sense to you unless you choose to engage and really participate in each one of these and look at the graphs and analyze what's going on there. Okay, we're going to look at phase shifts now, and a phase shift, that's your horizontal shift, can be written as the following. So it's that horizontal shift plus b kind of thing. This one is, this would be -1 would be our b times x minus pi over 2. So kind of a weird one here. But we're going to look at how these two are the same. That if I graph this, I graph this, I'm looking at the same graph. So cosine of x is half of pi ahead of sine. Okay. You can also see that I flip my sign. Okay, so this would be a reflection over the y, and then x minus pi over 2, that's also going to give me the same graph. This one right here, I think this one is more commonly seen, but they both are equivalent. Sine of x equals cosine of x minus pi over 2. In other words, sine of x is behind cosine by pi over 2. Now, how does this relate to the unit circle? You know, I kind of like to think back to the unit circle when I think about a lot of wave, because the wave can get a little bit confusing to me, but if it makes more sense to you, think about it that way. But if I'm thinking about pi over 2, which is like a quarter of the circle, right? It's 90 degrees. This guy right here is cosine, and this guy right here is sine. So if I look at cosine of x, okay, so let's come forward here to this one, because I'm going to be going backwards by pi over 2. If I look at cosine of pi over x, sorry, I'm saying that wrong. Let me see if I can get that clearer. Cosine of pi over 2 is x, right? Now if I shift the value back 90 degrees and I look at sine, I see that I have 0 and 0. They are equivalent. If you think of it in terms of sine, if I'm at sine and I go forward 90 degrees or pi over 2, I am at the value of cosine. So sine and cosine are matched here. So it kind of depends on how you want to look at it. If I wanted to look at cosine equals 1 here, cosine plus pi over 2 here is getting me to sine. Okay. Now look at it again. Cosine plus pi over 2 is getting me to sine. Now again, cosine of this value plus pi over 2 is getting me to sine. Okay. So I can also say that cosine of x plus pi over 2 equals sine. There it is. Cosine of x, pi over 2. I'm now where sine is. Now go back to cosine. So we're going to look at this now on Desmos. This right down here, these notes, this is just on whether tan is odd or even, so I did hope that you take the time to analyze whether it was which, but if you want to check your answer, it's odd. So let's go to Desmos. Whoop. All right, I did not mean to do that. I just want to go here. Desmos. Okay, we're going to open a graph and we're going to look at phase shift on our functions. Open. Okay, here's cosine of x, and here's that sine of x plus something. Now, this a is set up in terms of pi over 2, so I've gone up to 3 pi, I've gone down to negative 3 pi, and every time I take a step here, that value, there we go, that value right there is equivalent to pi over 2 approximately. There's pi, there's 3 pi over 2, there's 4 pi over 2, or 2 pi, right? So here they are different. Okay. Now, look, I've gone forward pi over 2, and they are the same. They are the same graph. Okay, what if I go back one more half pi step? Okay, now they're out of line again. Now, there's 3 pi over 2. Nope, that's not the same. There's 4 pi. Nope, not the same. Oh, weird. 5 pi over 2 puts me back in line again. So I want you to answer this question to yourself. If you want to write it down in your notes and then respond to it, we can talk about it the next time I see you on class. Okay. Why is it that, so we've got them, they're different here, and then they're the same at pi over 2, but they don't overlap again until 5 pi over 2. Why is that? So answer that question. Why is it that x plus pi over 2 is going to be equivalent to cosine? And why is it equivalent that x plus 5 pi over 2 is equivalent to that? So I want you to think about why those two things line up and respond to that question. I'm going to hide this guy now. Here's the other version. There you're seeing it the same thing. Seeing those lining up. Okay. Now we're going to hide these. We're going to come down here. We're going to do the same kind of thing with phase shifts, and we're going to look at sine. Oh, there's sine. Okay. Here is cosine. And there is our A. So I'm going to grab this, put it back to 0. Now they're not in line. Half pi step they are. Full pi step they're not. There's 3 pi over 2. There's 4 pi over 2. And there's 5 pi over 2. It worked again. Weird. So why is that working? I'm going to put one more in here. I was saying that I thought that maybe cosine of x plus a would be the same. So they're different. They're not the same there. There they are the same. Are the same. So negative pi over 2. Are not the same at pi. are not the same at pi over 2, but they are the same at 3 pi over 2. So I want you to think about that. If I take cosine, we can go back to our unit circle. If I take cosine, which is our x value, and I go forward, three pi over 2. So here's cosine of theta, sine of theta. So if I go forward and say 0 plus 3 pi over 2 and take cosine of 3 pi over 2, what is that value? Here that value is 0, which is equivalent to sine here, also 0. So let me show you my picture. Okay. So that's what that visual looks like right there. Okay, so reflect on that. Can you see any other patterns? Can you make any others come true? So when we tested this theory right here, it did not work. Uh-oh, so why did it not work? Okay, I'm going to close this and type QuickTime.